This video covers two methods for measuring distance, radar ranging and parallax. Before getting started, a couple of distance units need to be introduced. The astronomical unit is defined as the average distance between the Earth and the Sun. That distance is about 93 million miles. The parsec is about 3.26 light years. When parallax measurement is introduced, it will become more apparent why another unit so close to the light year is useful. As shown in the slide, a parsec is much larger than the astronomical unit. Radar ranging involves a radio pulse that is transmitted from an antenna and bounced of a target object of interest. For some objects, like the Moon, a laser pulse is used. When the reflected pulse returns, the elapsed time for the round trip is recorded. Radio is a type of light or electromagnetic wave that travels at the speed of light. The elapsed time can then be used to calculate the distance. The distance is equal to the speed multiplied by half the time. Only half the time is used since the distance to the object is half the round-trip distance. This method requires there to be enough reflected signal to detect. The target object has to be large enough and close enough to reflect a sufficient amount of signal. From Earth, radar ranging is used to measure distances to objects such as nearby asteroids, the Moon and neighboring planets. As an example, suppose it takes 2.53 seconds for a laser pulse to go to the Moon, bounce off a reflector that was placed there by Apollo astronauts, and return to Earth. How far is the Moon in miles? To solve this, multiply the time by 1/2 and multiply by the speed of light, 186,000 miles per second. One then gets an answer of 235,000 miles. Parallax is the apparent shift in the angular position of a foreground object, with respect to a more distant background, when one's position changes. It involves the apparent movement of foreground objects compared to much more distant background when one moves around. Your eyes view the world from slightly different positions. Your brain processes this information and tells you which objects are closer and which are farther away. Thus, you have depth perception. Hold your finger out in front of your face and alternatively blink your right eye and your left eye. You will see the apparent position of your finger shift back and forth. Holding your finger closer to your face causes there to be a greater shift in position. In general, the closer an object, the greater the measured parallax. Just what exactly is measured? To get the most precise measurement of distance as possible, there needs to be the largest movement as possible. When on Earth, this is done by looking at how much an object shifts when we observe it while the Earth orbits the Sun. A measurement is made, then again 6 months later. This is shown with unrealistically large angles for illustrative purposes. The angular position of the foreground star is measured in January and then compared with the angular position in July. The difference in angular position is called the angular displacement. Half the angular displacement is the parallax angle. This is P in the illustration. To calculate the distance, one takes 1 and divides by the parallax angle where the angle is in arcseconds. The distance will be in parsecs. That is, a star with a parallax angle of 1 arcsecond is 1 parsec away. This method is used to find distance out to about 10,000 light years. Beyond that, the parallax angles are too small to measure. As an example, suppose star A shows a parallactic shift of 0.10 arcseconds. Dividing 1 by 0.10 gives a distance of 10 parsecs.